This is a recording for math analysis, and it is the second part of the notes for 10-2. So this is 10-2, part 2. And this is for the second day that I think I'll be gone. And so we ended yesterday with you trying to add the numbers from 1 to 100. And so just curious about how you did on that. And the answer is that when you add those together, it's 5,050. And we'll just kind of see how many people got that as we go. So there happens to be a little story about Carl Friedrich Gauss, and I pasted on the next slide just to kind of show you quickly. And this is what we're going over. And this is somebody who posted on a math site that I look at. And it says, I love the story of Carl Friedrich Gauss, who as an elementary student in the late 1700s, amazed his teacher with how quickly he found the sum of the integers from 1 to 100 to be 5,050. Gauss recognized that he had 50 pairs of numbers when he added the first and last number in the series, the second and the second last number in the series, and so on. For example, 1 plus 100, 2 plus 99, 3 plus 98, and so on, and each pair had a sum of 101. And so then the 50 pairs of times 101, the sum of each pair, is 5,050. And then I'm just going to go through this, what's on the bottom here, because that pertains to what we're going to look at in the next slide in our lesson. And another way to represent that is if you write the numbers from 1 to 100, from low to high, and then you underneath of that, you write them again from high to low, and then you add all those sums, so you get the 101s all the way through, and then that gives you 100 situations where they add 100 add-ins of 101, and so that gives you 10,100. But because you use the list twice, it was doubled, so we have to divide by 2, and that gives us the 5,050. So really, that writing it forwards and writing it backwards and then adding them together and dividing by 2, you can kind of see where we're going to come up with our next thing. So we're going to add the first and the last number in an arithmetic series meaning that we're adding them together now instead of just listing them out with a comma. If we add that first and that last one, and we take how many numbers we have, in this case there were 100, and then divide that by 2. So 100 divided by 2 times 1 plus 100. So the first term plus the last term, and then we take the number of terms divided by 2, and then we find the product of those two things. And that is kind of the way that we can do that problem. So now you're going to write some notes about an arithmetic series, and that is the sum of the terms in an arithmetic sequence. And so they just listed a few there. It's up to you if you're going to write that. An arithmetic sequence, an arithmetic series, and just the listing, and then the series is the sum. A sub 1 is that first term, A sub n is the last, as here A sub 1 and A sub n. And then this goes through a very generalized approach for developing this formula, and so hopefully that numerical example was a very good one for you. And so if we have them from A sub 1 to A sub n, and then we list them from A sub n to A sub 1, we add all those together, and then that's 2 of those sums, and then when we divide it by 2, we get this formula that we'll be using. And we have 2 versions of that, and I will go over kind of what those 2 versions entail. So this is what you need to write down: the sum of an arithmetic series. So the sum of a finite arithmetic series with n terms, or the nth partial sum of an infinite arithmetic series. So if it goes on forever, we're kind of picking a grouping of those 2 add together. And you can use one of these 2 related formulas. So formula 1 that you should be writing is S sub n equals n divided by 2 times a sub 1 plus a sub n. And the second one comes from, suppose I don't know that last term, and how can I get that? So I'll just derive that one really quickly for you right here. You know that the nth term, a sub n, is equal to a sub 1 plus parentheses n minus 1 times d. And so essentially to get this, we can take that sum formula, to get the second formula, we can take this sum formula, S sub n equals n divided by 2 times a sub 1 plus, and then we'll just plug that all in as a sub n. So a sub 1 plus n minus 1 d. And then as we just combine the a sub 1 and plus a sub 1 is 2a sub 1, then we get S sub n equals n divided by 2 times 2a sub 1 plus parentheses n minus 1, close the parentheses, d. And so that's how we get, that was formula 1, is that first one. Formula 2 is S sub n equals n divided by 2 times 2a sub 1. 2a sub 1 plus parentheses n minus 1, close the parentheses, d. And so in my mind, if you know the first formula and from before how to find that nth term, you can find any term as you go. So now we're just going to use these ideas and find the sum of some series. And just to let you know, I skipped problem 5, and problem 5 is on finding the second differences, and we're not going to do that section right now. And so then now we're at 6a. So we left off with 4 probably, and now we're at 6a. So 6a is we're going to find the sum of -3 plus 2 plus 7 plus 12 plus ... plus 157. So maybe we aren't sure how many terms there are here as we look at that, but let's see what are some things we do know. So we do know that a sub 1 is -3. And we can get our common difference d by taking 2 minus -3. Any term, subtract its preceding term. So our common difference is 5. Oops, d equals 5. And in this one, even if we don't know how many terms there are, we do know what a sub n is. A sub n is 157. So now we kind of have everything that we need to know except for n. And so the next thing we're going to do is we will take maybe this nth term right here, and we'll use our a sub n formula. We know a sub n is a sub 1 plus parentheses n minus 1 in parentheses d. And you want to be super familiar with that formula as you're going through these. And so then we can call a sub n 157 equals a sub 1, we know is that -3, plus n is what we're trying to figure out, so we'll leave n minus 1, and then d, our common difference, we came up with as 5. And then just we'll take a moment and solve for n. Since I'm not here, I won't ask you guys. I'll just kind of figure that out as I go. So 157 is -3 plus 5n minus 5. 157 is -8 plus 5n. Add 8 to each side. 165 is 5n. Divide by 5, and 33 is equal to n. And so now I have how many terms there are. I need that information. I have my a sub n term, and I have my a sub 1 term. And so now I can use the formula S sub n equals n divided by 2, parentheses, a sub 1 plus a sub n. And so S sub 33, if I want to put that there because I know now that n is 33 divided by 2 times in parentheses -3 plus 157. And so then going through that, S sub 33 is 33 over 2 times 154. And then when we get that, S sub n, or S sub 33, is equal to 2,541. Just check on your calculator that that's what you can get for that one as you go. Then in our next one, we're going to do another sum, and this one will be a partial sum. So this goes on forever, but we're just finding the 17th partial sum of the arithmetic series. So make sure, oops, this is 6b. Make sure that you're writing a good note about what this is actually the sum of. So we're going to find the 17th partial sum. And it is an arithmetic series, just kind of thinking ahead to your next quest to quiz and test together, that we are going to have geometric series as well. So we'll have to make that determination when we're taking a test. But right now we're told it's an arithmetic series. Arithmetic series. And it goes 53 plus 31 plus 9 plus ... So it goes on forever, but we're just looking at kind of parts of it. So a sub 1 is equal to 53. Our common difference, D, is found by taking 31 minus 53. Or 9 minus 31, whatever works for you. And that's -22. And then in this case, we know that n is 17, and we don't know that last term, a sub n. So you can either figure out what a sub n is, or you can use that alternate formula. And so I'm going to use that alternate formula. I'm going to derive it again because I don't really keep it in my head. So S sub n is n minus 2 times a sub 1 plus a sub 1 plus n minus 1 in parentheses times d. So then S sub n is n divided by 2 times 2a sub 1 plus n minus 1 d. And so I just replaced the a sub n with that way to find that as I go. So here's our formula that we're going to use. We know n, we know a sub 1, and we know d. So we're going to find S sub 17, and that is 17 over 2 times 2 times 53, which is a sub 1, plus, and then we'll take 17 minus 1, and then times that common difference, which in this case is -22. I'm not using brackets and nested parentheses, but I think I have all the parentheses that I need there. So this is 17 over 2 times, I'll put a bracket in there then, 2 times 53 is 106 plus 16 times -22. And of course, you know, if you have a calculator, you're maybe using that. And this is 17 over 2 times 106 minus 352. And then that's 17 over 2 times -246. And so our final answer of S sub 17, and I wasn't writing that every time, is -2091. And it is okay to have a negative value there as we go through those. So that's the second sum formula that we got. So generally, it's just kind of figuring out what the parts are that you know and kind of using those parts as you go through these problems. So then our next problem, which is 6C, is using that summation formula formatting. So the sum from n equals 10 to 32 of n plus 6. And so in this one, we have to figure out the number of terms. And to find the number of terms, because we're going from 10 to 32 and we're including the 10 and the 32, we can take 32 minus 10, but then we have to add one more, so that's 23. And hopefully we've talked about that. If not, that should make sense to you. And so then that means that n is 23. The first term, which is a sub 1, is just going to be, since n equals 10 to begin with. So by the way, this is my n for number of terms for finding that, not the same as that n that is in the formula. And so a sub 1 is going to be 10 plus 6, so that's 16. And our last term, which is a sub n, is, well, we know our last n value is 32, so that's going to be 32 plus 6, so that's going to be 38. And so now we can use the summation formula where s sub n equals n divided by 2 times a sub 1 plus a sub n, and just plug in the values that we have. So s sub n equals 23 divided by 2 times, in parentheses, 16 plus 38. And then, you know, we could have called this S sub 23. Maybe I'll change that right now. S sub 23 is 23 over 2 times 54. And then S sub 23 is 621. So just make sure you're making careful notes of those 3 different kinds. There might even be a couple other ways that we could do this as we go through those. Then we're going to look at an application problem. And so for this application problem, we kind of have to think about what's happening here as we go through this. So an artist receives royalties for all CDs of his music that are sold. Just a second. And okay, and for the first 10,000 CDs sold, the artist receives $10,000, and he receives $12,500 for the next 10,000 CDs, $15,000 for the next 10,000 CDs, and so on. How much money will he receive if 500,000 of his CDs are sold? So this is number 7, and we'll just kind of write a little bit about the sequence here. So the first thing, and this is kind of our monetary values, he gets $10,000, and then he gets $12,500, and maybe I'm going to rewrite that without commas in my numbers here. So we have $10,000. Oh, I just want to write a comma there. 10,000, then 12,500. And so that's what we're kind of looking at as we go. Then the next one is 15,000. And up to 500,000 as we go. So then we need to find the sum, and so the first thing we want to think about is, oops, we're up to 500,000 at the end there, and then we want to figure out how many numbers there are. So if I just take 50 divide 500,000 divided by 10,000, because I need to find out how many 10,000s are in there as we go through. And so there are, if I do a lot of canceling off there, there are 50 sets of 10,000 CDs sold. So our N is equal to 50. And so then we have our N value. We know that A sub 1 is this $10,000. So there's a lot of 10,000s in there. We know that our common difference, D, is 12,500 minus 10,000. And so D is equal to 2,500. And then in this case, you know, we could either use the formula with A sub n replaced with A sub 1 plus n minus 1d, or we can find that. And I just am going to, just for something different, I'm just going to find A sub n, which is A sub 1 plus n minus 1 in parentheses d. And so to find that, we're going to find A sub 50 is A sub 1, 10,000, plus 50 minus 1 times D, which is the 2,500. And so that is 10,000 plus 49 times 2,500, and that A sub 50 turns out to be $132,500 dollars in that one. And so then we need to find the sum, and I'll slide this up a little bit. And to find the sum, now I'm going to use the original sum for number 1, formula 1. S sub n is n minus 2 times A sub 1 plus A sub n, and then this is S sub 50 is 50 divided by 2 times 10,000 plus 132,500. And so if you want to take a moment and figure that out, you can do that. And that will give you a sum of 3,562,500. So that is a total of $3,562,500. And so that is our total sales for that one. There's one more example that I want to look at, and this one is Anna sells clothing in a store at a mall. Her commission on the sale of new seasonal merchandise is $3.50 per item, costing at least $25. To encourage an increase in sales, the store manager promises a 5-cent increase in commission for each additional item sold. Thus, on the sale of the next item, Anna will earn $3.55 in commission. On the sale of the third item, she'll earn $3.60, and so on. How many items worth $25 or more will Anna need to sell for her total commission on new merchandise to be at least $1,000? So this is a little different situation, and we'll call this 8. This is number 8. And so I'm going to write those commissions. She gets $350, and then $355, and then $360. And so in this case, we want to know when that sum is at least $1,000. So I'm going to kind of write it as $1,000. So our S sub n is 1,000. And our common difference, D, 3.55, oops, minus 3.50, so that's 0.05. N is what we aren't sure of, but we know A sub 1 is $3.50. So for this one, I'm going to use that little longer version where S sub n equals n divided by 2 times 2A sub 1, 2 times A sub 1, 2 times A sub 1 plus parentheses n minus 1 d. And in this case, let's think about what we can put in there. We've got the 1,000 for S sub n as a minimum. We've got n that we don't know, divided by 2, and then, oops, equals, and then we've got 2 times the a sub 1, which is 3.50, plus n minus 1, in parentheses, times that common difference, which is 0.05. Oops, I put one with a bracket and one with a parentheses, and minus 1 times 0.05. So I'll just keep that as nested parentheses. So let's take a minute and figure that out. So 1,000 equals n divided by 2 times 7 plus 0.05n minus 0.05. And 7, let me just pause a moment here. And so when we do a little bit of, let's divide by, or distribute that n divided by 2. So I've got 1,000 equals 3.5n plus half of that, 0.025 n squared, and then minus 0.025 n. So distributing my n divided by 2, I'm going to get one side equal to 0, and I'm going to write that as a quadratic then. I'll get 0 equals 0.025 n squared, and then combining my n terms, it'll be plus 3.475 n, and then minus 1,000. Now, that's just awkward to work with, so I'm going to take and divide both sides by 0.025, and that'll make n squared into an easier to manage problem. So I'll get 0 equals n squared plus 139n minus 40,000. And now I have a quadratic, and I'll ask that you put that in the quadratic formula and then see what you get for n. And I'm going to have to leave that for you to do. And so you can pause this right now and figure out what n has to be, and then I will show you that answer in just a moment. So if you didn't pause it now. If you did pause it, you should get, when you use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The n that you get, or n equals, should have been 142.23. So 143 items must be sold. And the second value is negative, and we can't have a negative value. So that is the rest of 10.2. And now you can work on the homework for this, or there maybe are some in-class problems if you would like to do those, or if you're asked to do those. See you tomorrow.